Hello everybody. Alright, in this video I'm going to talk about tramming a bed, also known as leveling, but more correctly it's known as tramming, and the difference between leveling your bed and Z offset. There's a lot of confusion out there. There's a lot of people that are very confused on what the two things are. They are related, but they are not the same thing at all. One is a static setting and one is a dynamic setting. And what that means is a static setting is meant to be set once and it stays like that forever. With obviously you'll need adjustments, but it's supposed to stay the same. A dynamic setting is something that you can adjust constantly. So in that case, what we're looking at here is we're going to talk about tramming, also known as leveling, first. And what that means is that this bed has two planes. It has an X plane, which is left to right, and it has the Y plane, which is front to back. Okay, on those two planes, the intersection of this nozzle, the height of it, should be the same when the bed is level, because this bed is not supposed to change. This height to this height is a relative distance that should always be the same. So if this nozzle was 2 millimeters off of the bed back here in this corner, then no matter where this thing moves along these two planes, it should always remain 2 millimeters. Alright, if this corner was low and you get over here, it's going to be like 2.5 millimeters distance. And if this corner was high when you get over here, it's going to be like a 1.5 millimeter difference. And that's going to throw your entire print, your adhesion and everything off. So the goal is to get this nozzle to a consistent height no matter where it is along these planes, no matter what. It could be 25 millimeters up in the air, and then no matter where I put the nozzle over the bed, it'll still be 25 millimeters. That's what I mean by a consistent height, and that is the goal of leveling. Once that is set, you shouldn't have to touch that anymore. The other adjustments that you're going to make for your adhesion are generally made off of Z offset. Now, that being said, it's very difficult to get this exactly right without a probe. There are ways to do a live leveling test, and I will get into that later on in this video. But for right now, we're going to talk about the basics of getting your first rough adjustment leveling done. Because right now, I've thrown this machine completely out of whack. Nothing on this machine is right now. I set it that way for the purposes of this video. The machine that we're working on here is an Ender 3 Pro. It's not a V2, it's not anything fancy, it does not have the probe. So this is going to be a run-of-the-mill, typical Ender 3. This one has the noisy board in it, hasn't been upgraded yet. And on the Ender 3, you're going to find your limit switches over here. This limit switch is your Z-axis limit switch. As you can see, it says Z right there on the wire. What this does is it tells the machine where the home position is when it's setting up its home. And for the machine's home position, that tells the machine that when this switch is clicked, that is my 0 of my axis. So anything above that's going to be a positive number, anything below that would be a negative number. When this is clicked, it's telling this machine that's 0. So the first thing I'm going to do is I'm going to set this bed height. And the way we do that is the first thing I always do when I level a bed, especially on the first time, I'm going to turn all my knobs all the way to the left to tighten the bed down. Alright, I'll tighten them all up. Not to the left. This is confusing on the knob thing. This is the way I've learned to figure this out. If you're looking at the front of this knob, you want to turn to the right, that will tighten the board. If you turn to the left, that will loosen the board. So right, using the front here, right is tight, left is loose. So right tight, left loose. So by turning this way, I am loosening the board. If I turn this way, I'm tightening this thing down. Alright, so what we want to do is we want to tighten these all the way down until they pretty much won't tighten anymore. Then we're going to back them off about the same amount. The way I do this, I usually put my finger on here and I just kind of turn this. So I'll just kind of go like 1, 2, 3, 4. Back here, 1, 2, 3, 4. What I'm doing, I'm putting my finger like up the front of the wheel here, and I'm just pulling back to about here. So from top to the back here, and then I do the same on the other side. 1, 2, 3, 4. 1, 2, 3, 4. I apologize if this keeps going out of frame. It's very hard to watch the camera. It's mounted to my head and see where you guys are looking. So hopefully it comes out alright. Alright, so now the next thing I'm going to do is I'm going to set up my limit switch, because I've brought this bed all the way down and then backed it off by a certain amount. That preloads these springs under here, and if you don't have the yellow springs, or at least the silicone studs, one of the two, whichever you prefer, make sure you get those. You can see here, these are the yellow springs. If you have the silver springs, you really need to upgrade them. They're very inexpensive, very easy to change out, and it'll make your life so much better. Those silver springs do not hold a level for anything. They're awful. Alright, anyway, we'll go back to this. So now that I've brought the board all the way down, I brought it back up by a certain amount of turns. These springs are preloaded to about 80% of what they are. That means that I can still bring the board down some if I need to adjust down. I have room to do it, but they're held way down tight, and they're not going to want to back off over time. They're going to want to stay right where they are. It's kind of an advantage of doing that. So now I put the piece of paper under the nozzle, and I center the nozzle over the bed. Alright, so next thing I'm going to do is I'm going to adjust my Z limit switch. I know for a fact that it's not right, so I'm going to go ahead and bring it down. What you want to do is you're waiting for this piece of paper to get contacted by the nozzle. Right there. And what you want to hear is this click when it contacts. So as I bring it down, it's going to be hard to hear with all the background noise, the fans and everything, but that's going to make a click. I'm bringing it down very slowly, and the way I'm doing that is my fingers are on this coupler back here. Right here. I'm just using my fingers to turn this, which turns the gear, which moves the axis. Okay, so I'll bring them down. There's that click. I don't know if you can hear it, but there it is. It's that little click out of that switch. So I just bring it down, I hear the click, and I stop. Now you're going to notice this paper is way too loose. So that means that this limit switch is too high. It's stopping this axis before contact. So I'm going to go ahead and I'm going to make an adjustment to that. So I loosen these two nuts up. You do not have to take these out or anything. You're just going to crack them loose. There's one. It's a little bit to get it moving. And then the top one, there's two of them here. So you can see that. There's the other. Okay. Don't go too loose, because then you'll have something like that happen. It'll fall off. They're just those little T-nuts behind it that are locked into this extrusion. So if you loosen it too much, you can actually remove the switch. You don't want to remove it. You just want to loosen it. So okay. Now, I'm going to bring this down some. And I'm going to bring this board down until it hits this paper. Or the head down, rather. Bring the nozzle down to the paper. And right about there. I want to make it so it's just kind of scratching it. I don't want to make it, super, super tight. That's pretty good right there. So now that the switch is loose, see if you can see this. What I'm going to do is I'm going to bring the switch up till it clicks right there. I need two hands to do this. So I'm just sliding it up very slowly and gently. It's kind of tricky to do. Just until it clicks. Gently tighten a nut down, just one of them, and test it. Alright, so now it's depressed. The switch is activated. The paper is barely touching. I pick this up, and there goes the click. You hear it release, bring it down, it clicks, and it moved down a little bit. So I'm going to bring this up, and I'm going to bring the switch up just a hair. Just a little bit. Alright, let's try that. Bring this down. There's the click, still not enough. I gotta go down a little bit. I'm sorry, I went up last time. Down just a hair. Let's try that. Close. It's starting to scratch. I get my click, but I want just a little more. Just a hair down. There we go. So I got right there. Got some tension. You can hear it. And I just barely clicked that. So that means as soon as that switch hits, that's going to be where that is going to consider that nozzle zeroed. So I'm going to go ahead and lock this down by tightening the 2 bolts. 1, 2. I want to point out something real quick I just thought of. This Ender 3 Pro has a glass bed. You may not have a glass bed on yours. You might have the standard bed that comes with it, or you might have a sheet, PI sheet, anything like that. If you do, this switch is probably not going to go down low enough for you. And that is because right here, there's a tiny piece of plastic that they send out as like a stop. That doesn't need to be there. And in a second, it's not going to be there. So, because we control the depth of the switch with these 2 bolts, we don't really need the stop here. It's not like there's anything pressing down the switch and that's not doing anything anyway. So, take these, and do a little bit of surgery. Watch your eyes when you do this. All I do is I grab a hold of this tab right here with the things and squeeze it, take it off. There, and I cut that little tab off. So now, if your switch needed to go lower because this isn't as thick as mine is, on this machine, this is got the glass plate that adds height. So you can see how close that was. If I was going down to the rubber mat, I would need a little more down. That would be in the way. Now it's not. So you can adjust the full run of this without that tab being in the way. Not sure why they did that. They stopped doing it after a while, so they must have realized, yeah, this was a bad idea. So, anyway, I digress. Now, what we have achieved is we have set my Z limit switch pretty close to 0, where this is going to home right there at 0. Now, the only point on this bed right now that is level is the middle. The reason why you can say that is because if you think about this like a seesaw in this direction or this direction, when you're tightening or loosening the beds, it does this, right? And if you know anything about the whole thing of science and the fulcrum, it's right dead in the center. So this was a seesaw. This is the point that it would be seesawing on, which means it doesn't move. This bar would be here, the board would be across it, doesn't move. All right. So this point in the middle of the bed and the point the same way this way, no matter what, is always going to be as level as it's going to be. No matter the height, doesn't matter. When this nozzle is in contact with this bed in the middle, it's going to be like a seesaw, so that's always going to be the most level point from the beginning. So now that we've got that done, we're going to do rough balancing of these wheels. We're going to get it so it's somewhat level. We're not going to do a perfect leveling right now. We're just going to do a rough leveling, the initial one. So when you're moving this, be careful, because the head can contact the surface and it can scratch it. Now you can see here, this one's way off. However, this one, way too tight. And that's what I'm talking about, where we can scratch it. You hear it grinding right there. It's because this nozzle is so tight. You see the little line it made on there? It'll make a line in this. It'll gouge this up if you go really fast. So it'll go slow and careful. But I know that wheel's going to be way too high. And the back is going to be way too high too. I can hear it. Right there. You can hear it starting to scratch. Okay, so we're going to go over here. We're going to start get that like a good turn in. So I just lowered the bed a little bit. Still not quite enough. So turn some more. And I'm going to get this piece of paper under there. Now when you're doing this, a bad habit to have is to have your hand resting on the bed, on the corner, hanging on a wheel. It all will affect. If I push down on this, it's loose, and I let go, it's tight. So it doesn't take much to change the spring height. So keep your hands off, all the weight off. Handle the paper just by the edge like this. So now you can see I'm just a little loose, so I need to bring this bed up. So I'm going to loosen the screw, which brings the bed up. I like that right there. Just a bit of scratch. Okay, let's go up to this one. Loose, so I'm going to loosen the bed because I want to, it's too far down, so I'm going to bring it up to meet the nozzle. Okay, this one was really off. Now this is going to change as I go all around. I can guarantee you that. Okay, so right about, you see I keep letting go of the wheel while moving the paper. Right about there. Okay. Come back here, this one's kind of tight. I'll tighten down the bed to pull it away from the nozzle. There it is. Yeah, right about there. That's a good amount of scratch. Don't worry about it being perfect right now. This is just a rough pass. And again, the same thing. And you see I just hit my arm on the thing. It's really easy to get in the habit. Don't do it. Keep your arm up. Okay, we're going to tighten this wheel because this is not moving. And we're going to scratch it. Yeah, it feels pretty good. That's not bad. Now, once I've done it once, I'm going to go around at least 3 times. So, second pass. Oh, look at that. See? This is why we do it. Second pass. It's going to be less of an adjustment every pass. The reason this happens is each wheel affects the other wheels. So when you tighten that corner down, it could change this. So by going around a couple different times, it's going to eventually level out the more you adjust it. So this one's now, it's a little loose, which means I need to bring the bed up to meet the nozzle a little bit. So we're going to loosen it up. So remember, lefty-loosey in the front of the wheel here, so just a little bit. And you saw how much I moved it, Jay. It wasn't much. It's actually a little too much. Bring it back. Little movements. Back. Back. I like the feel of that one. Okay, over here. Too loose. So we're going to go ahead and loosen the bed up a little. Turning towards the left. That's pretty good. It's a little tight, so I'm going to go just a little bit down. So I'll turn to the right now. Back and forth until you get it just right. There we go. Back here, loose. Kind of expected it to be because I tightened the hell out of this one. So I'm going to loosen it up. Okay. This one's tight. We're going to tighten down the bed. But I went all the way down to the springs. That's okay. And it got tight all the way. If it gets to the point where you're tightening down the bed and you don't have any more down left, bring your switch up just a hair and reset your wheels again. That'll give you a little more adjustment. I like to run these really, really tight so they stay that way. So sometimes it's going to run into, you're going to run out of adjustment down. And that's what you just have to do, is you just have to go back and just change this a little higher, just a touch. But this was enough to make it. This one's now a little loose. This is pass number 3, and I'm barely touching these wheels. I'm just backing it just a little bit. This one's just a touch tight. That one's pretty good. And now that I've made adjustments, I'll check one more time. Run around till you should go around until you don't have to adjust anything anymore. That one's just a bit tight, so I'm just going to tighten it a little more. Okay, that one's good. That one's good. That one's good. And this one is good. So now that you've got those all set, you come in the center here. It might be a little off if your bed is a little bit off, but it should be pretty close. And you can tell by the sound of that, it's good. Alright, so that is how I cold level. Now I'm going to stop the video here for a second, and then I'll preheat the bed. Be right back. Okay, so now that I've gone ahead and gone around the board and done a cold initial leveling, I've got my limit switch set, so everything here is all set up. Alright, so now what I'm going to do is I'm going to go ahead, I'm going to do 2 things. First thing I'm going to do is I'm going to go ahead and preheat this board and the nozzle, so I'm going to tell it to preheat both. And by doing that, I'm going to heat everything up. So the reason we do it hot, we do another pass hot, is that's how your printer usually is. The bed is warm, the nozzle's hot, and it can change through contractions and expansions and contractions. It can change how this sets. So I want to get this up to temperature. As you can see now, the bed's heating up, the nozzle's heating up. And the other thing I want to do is I want to go ahead and home this machine. So motion, auto home. For those of you who've never heard a non-silent board before, this will be a treat for you, because this is what it sounds like when you don't have that silent board. Silent board is worth every penny, because they're pretty loud. So now when it homes to this corner, but I want to actually be able to move this around again. You can't now, because it's, once it homes, it locks up the motors. So you can go into motion and disable your steppers, and that allows you to have this back again. Alright, so now let's go back to main info screen and we'll see what we're doing. We're still a little cool, so I'll give it a minute. I'll pause this, I'll be right back. Okay, welcome back. I let the machine heat up the bed, so now we're ready to go. Nozzle's up to temperature, bed's up by temperature. And you're going to find that the paper is going to be a little tough to put under here because we have this so close. So we pretty much have this set. So for the first time, I kind of just push down my finger on the corner of this bed right here and get it under there. Now that it's hot, you're going to notice that it's a little tighter than it was. It's not too bad. That's pretty close still. I might give it just a smidge tighter on the bed, away from the nozzle. But that feels pretty good right there. And then I keep the paper under the nozzle while I just move the bed down to this corner. Same thing. It's a little tight, so I'm going to pull that in a little. There we go. Heating it up does make a difference. Tight again. I'll give that a tighten. Okay. And this one just a little bit loose. Okay, that's pretty close to the others. Now that I made adjustments, I'm gonna just check it one more time. Oops, watch out for that fan. Just touched the cooling fan on the outside. I did not like that idea. Hey, this is tight now. That's why we double check these. I just barely touched the wheel. Now that's pretty good. Back here, a little bit looser than it was. That's pretty good. This one, once again, a little bit tighter than I want it. There we go. And that one's good where it is. One more pass. Just a little bit tight again. Good. Nope, get back under there. Yeah, my paper's getting kind of wrinkled up, so it gets tougher. Alright, and last pass. That feels good. That feels about the same. That feels about the same. That feels about the same. The middle feels good. There you go. So now that we've done that, that's pretty much a leveling done. We're not going to mess with that anymore. The next step that I would recommend, because we don't have a probe, is I would run a wide type test where I'm printing an entire border and several copies of that border. And the reason why you do that is it allows you to watch the plastic as it goes down, and you're looking for inconsistency. I don't care right now about how well it sticks, as long as it somewhat sticks, and it should. Don't worry about sticking as much as consistency. What you want to see is you want to see it laying a line down all the way around, and you want to compare. Is it thicker here, thinner here, thicker here, thinner here, etc. And as it comes around, you will notice that it's going to be in a corner that's usually it's going to be affected, or an entire side of this bed. And that's when you adjust these wheels to a live print just to fine tune everything. After that, hands off the wheels. That's it. We're done. So I'm going to go ahead and fire up a print for this, and I'm going to load some plastic in because I don't have any loaded in. And then I will show you what I'm talking about with the square. And when, like I said, we're not going to do Z offset yet. That comes next. But right now we just want to make sure this is nice and level, because if this is not consistently set, setting a Z offset is almost impossible. This has to be done first. Alright, so I'll be right back and load all the plastic up and all that good stuff. Take 3. Okay, so I'm going to go ahead and show you how to set up that large print I was talking about, where it's going to put plastic all along the borders here. near the corner screws. That's kind of the point. We want to make sure these outside borders are going to be consistent when it lays down plastic with the leveling that we just did. So I'm going to grab my calibration cube file and I'm going to bring it over. Alright, I'm going to go ahead and make this big for you. Okay, so now that this is on my screen, when I click on this, I get these tools over here on the right side. The second one down is the one I want, scaling. I'm going to make sure uniform scaling is turned on. That means when I change this, it changes all three. So let's go ahead and change this. This side is millimeters and this side is percentages. I want to change it by a size. I don't want to go by a percentage, so I want to go by size. And I'm going to go ahead and change this to 125 millimeters. Okay. And that makes it huge. I want it a little bigger than that. So I'm going to click on this again. I'm going to change this to, let's try 150. Closer. I think 175 might be too big though. Oops. Let's see. No, that'll work. So as you can see, it's going to put this cube right on the edges of my bed. Don't worry about the fact that this is huge and when I slice this, it's going to say it's going to take days to do. We're not going to print the whole thing. We're only going to print the border. And for the Z offset, the first layer. We'll never print more than the first layer on this test. But regardless, I'm going to go ahead and slice that up. And I'm going to save it to my removable drive. And go ahead and eject it. I'm going to put that in the machine. I'll be right back. Okay, so I'm letting this print the border like I was talking about. And you'll see here that it's pretty decent. Looks pretty good here. It feels a little high right here on this edge. The difference is the plastic feels round under my finger versus flat. And on the second pass, it becomes more obvious. You can see it looks pretty much the same from here to here, but here it might look a little bit different. It's a little thinner. So what I'm going to do is I'm going to adjust. It's too close right here. Right here you see this thin piece. This corner is a little too high, so I'm going to bring that in just a little bit. I'll try that. And over here, this all looks pretty consistent. I'm pretty happy with that. So let's see if this pass looks better here. Yeah, that looks a little better. I can see the white next to the last line. The next line is a little dark, a little brighter. So it looks okay. It doesn't feel too high. This front's looking okay now. That one corner brought both of these down. Alright, so now we're going to get into Z offset. And before I let you see that part of it, before I explain this, I'm going to go ahead and pause both the machine and the video here and talk about that next. Okay, I don't know if the resume will work. Pausing is a little tricky with printers, but I'm going to talk about this real quick. We've talked about the leveling of the bed and how that's a static setting. This bed level shouldn't change from where it is from time to time as we're printing. You might need to make adjustments here and there if it can be confirmed by this test that the level is off. And you'll know because one side will be light, one side will be heavy. Just like you see here, this border now looks pretty consistent. That is how you know your bed is level without a probe. Alright, so the Z offset is a variable that you can change, and you will change often, depending on which plastic you're running, what it likes for a squish level. These are all things that you're going to need to know. So what we're going to do next is we're going to run this test where it's going to do the first layer. And as it's laying down the plastic, we're going to look at how that looks. And there's a guide on my website that I've got from one of the groups where it shows the different pictures of too close to middle to too far, exactly how it should look, you know, for each setting. And you'll know by those pictures what you have. If you're too close, it's going to kind of be crushed down, might be really thin, transparent, might be just really grooved. If you're too far, it's going to be round, it's not going to be sticking, there's going to be gaps. And the better you are to getting it just right, it'll look like a sheet of plastic. So I'm going to go ahead and resume this print. And what I'm going to use in this menu is tune. Every printer has something like this tune menu. They're all a little different. But what you're basically looking for is either baby step Z, Z offset, something that has to do with Z offset. Now, baby step Z is going to allow me to adjust this live as we're going. Right now, there is no offset given. Where it's printing is the exact level it is for home, which is 0. It's telling me that right now that nozzle is not adjusted in any way. It's just printing at 0, which is what I set up for my leveling. Now, I can tell just by the little peaks that I'm getting of that material under that nozzle, as I'm going to show you next, is it's actually really good. And I don't want that. So I'm going to set it a little higher than it's supposed to be, just to screw this up on purpose, so I can show you what it looks like. I'll be right back. I want to see if that worked. Okay, so I stopped the print. So I put my flashlight over this so you can kind of see this. It's dark right there. Alright, so right around here you can see that this is relatively well stuck to the bed. There's good adhesion right here. I did have this little blob here. I don't know what that is. It might have been stuck to the nozzle. But all of this was pretty good until I started monkeying around with it. Because for whatever reason, it landed right where it needed to be, and I wanted it to fail. So I started raising the Z offset. And as you get into where I raised it, you'll see, look close enough, these are not stuck to the bed or each other. There's gaps between these lines. It's not adhering. This is too high. This was right, and now it's too high. It's so high, in fact, that I lost the plastic here. It actually came off in a big blob. So I'm going to go ahead and try to resume this and get it down to where it's laying down again. Then I'll give you an example too close. Okay, so now it's printing really good. It's actually printing perfect again. I had to pull the border off because it was all screwed up from that adjustment I made. But if you look closely at this right now, this is a perfect Z offset. I mean, this is really good. It is one sheet of plastic. There's literally no lines at all that I can see right here. They are picking up a little bit towards the edges, just where it changes direction because it slows down. So I might be able to adjust my flow later, but that's a different setting. But you can see that looks really nice. So now I'm going to change it. I'm actually going to go ahead and deliberately set this too close. So I'm going to go to my tune, I'm going to go to my baby step Z, and I'm actually going to crank this thing in by a good 2 to 3 millimeters. And it's going to get really unhappy with me in a minute. So that's 0.3. So not in by 2 millimeters, in by 0.3 millimeter. And it's going to make this pretty upset. We might even get some extruder clicking, I don't know. But you'll see what I'm talking about in the difference between that layer and what's about to happen. So I'm going to go ahead and pause it and we'll let it do its thing for a minute, and I'll be right back. Alright, let it run back and forth a couple times. It's to a point now where I can actually show you what I'm talking about. We are getting some extruder clicking. If you listen closely, you hear that noise. What that's telling me is the plastic is being fed into this, is getting backed up because there's no place to go. And if you look closely at this right here, you'll see that it looks way different. Too thin, kind of rough and transparent. Just not exactly right at all. So I'm going to go ahead to my tune. I'm going to go ahead and go back to where it was. So baby step Z. I need to go up now. So I'm going to make it a positive number. And I know that I set this by at least 2 to 3. So I'm going to go to 0.25 and bring it up. And instantly you can see it's returning to where it was. It already looks a lot better. So that's how you read the plastic as you're laying it out. You kind of look at what it's doing and run a test like this where it's a long print back and forth like this. It gives you time to kind of adjust. Let it run like 20 lines in a row like this, and then you can kind of feel how the plastic feels. You can look at it, look for gaps in your lines, look for any kind of like roughness, unevenness. Too close like that where it gets transparent. If it's the other way, if it's too far away, you're going to have the plastic's going to be coming up off the bed. It's going to be really round looking. You might have gaps between your lines, kind of like the very edge of the ends of this. Only it would be the whole thing. The pictures that I have available to show you, give examples of all three things: normal, too far, and too close. So I can always supplement what I'm talking about with those pictures later. I don't think I can put them into the video, like overlay them. If I can, I'll do it right here, I guess. But I don't know if I have the ability. If you see them, then I did. If not, then just let me know. I'll send you the pictures. But even here, you can see this is it's rough. It's looking okay, but you see the drag marks. If you look close enough at this plastic going down, this is why I say let it run for a while, because now I can see it. There's these little like grooves in this. It's dragging through, making a rough surface. Still too close. Again, I'm gonna go down to my tune, Z offset, about baby step Z. This one doesn't like remember where you were and display it. This firmware is just a little weird. It's an old one, but it doesn't matter. I know I need to go in a positive direction. I'm actually gonna go all the way up by 1.1. It might be too much and it might not, but we're gonna let it run a little while longer and see how that looks. I'll show you how that looks in a second. Okay, so I'm gonna take a quick up close look at this. Let's see if we can do it in the light. Well, I won't have to use a flashlight. I'll use two hands to point stuff. So back here, around here, this was looking pretty good. I liked the way this looked. It wasn't too bad. If you put a spotlight on it, you can see the lines. They're pretty well joined. There's not a whole lot going on there. Take the light away. It looks like a sheet of plastic. It feels really smooth. There's not a lot of problems I can pick up on that. But then I started messing with it just to show you guys what would happen. And here, you see, I went close with it, real close. This was so close that it was getting to a point here of extruder failure where it was clicking because it couldn't push the plastic anywhere. It was getting jammed up in the hot end. Do that long enough, you will get a clog. But that means it's just too damn close. You can see how it's kind of okay here as far as like laying down plastic. It's thick lines, it's rigid. There's a lot of bumps here. But then it disappears completely here, and then it comes back down here, and it starts getting through again. But it's really, really thin. It's barely there. So then I started adjusting from then on out. And I went up some, but it wasn't enough. You can still see that my nozzle was dragging through the plastic because it was so close, leaving these little bumps and roughness. This is because there's too much plastic going down around the nozzle. That's what causes this. It still has no place to go where it's supposed to, so it kind of just splays out to the sides, clumps, and just makes a real general mess. And you can see it's getting lighter and lighter as I go because I was adjusting it. Here I've got another adjustment in. It's still a little bit too close because it's a little too thin, but it is getting smoother. So then I went with another large adjustment, and for a second it was really good again. You can see this stripe right here where it was nice, joined, no gaps. But then you can start to see, I'm going to put the light on again, you can really start to see these gaps starting to appear again because I went too high. So I went from too low to too high, and you can see I have poor adhesion right there. I had some plastic peel up off the edges. I've got gaps between my lines. It just doesn't look so great. And then I fine-tuned it down and got it to the point where you see here. Take the light away, so I don't need it anymore. Trying to keep this to focus, guys. I know it's not great. But here it is. You see here, this looks pretty good. Nice joined lines right here. This would normally be in the border that I took off, so don't mind that. You can see how loose these were when I was too far. I can pick them right up and peel them right off the bed, where these other ones I can't. I could with enough force, obviously, but not just by touching them. Like these guys just want to go. Yeah, see right there? They just want to move. They are not stuck. So here we are again with the perfect spot. Looked really great, and you can see that we ended up back there again by live adjusting my Z offset. So to recap the Z offset compared to the bed itself is a static setting. That means this bed should not move under normal circumstances as far as height. This, and this are all the same height. Anywhere on this bed is the same height relative to any piece of the machine that does not change its height. So from here to here right now, this is the same no matter where I am on the bed. If I put it here and measure to this point, it would be the same as here, as here, as here, as anywhere. So this moves, that's fine. But the distance, relative distance from this to this at all times is going to be the same no matter where it is. So whatever height this is, whatever distance this is, it's always the same. That is bed leveling or tramming. Tramming means making this bed the same as this. Alright. So the nozzle always knows when it's zeroed out, it's going to be touching the bed, it's going to be touching the bed, it's going to be touching the bed, and so on. Static setting doesn't change. Z offset is the setting that the machine puts the nozzle above the bed. So to the machine, it thinks that this bed is the same no matter where it is, and because it's the same no matter where it is, by setting the nozzle negative 0.3 whatever, that means that plastic is going to be touching the bed just right, if that was the setting. It doesn't matter what that setting is. The machine thinks 0 is where this bed is completely flat and the nozzle is hovering just above it, and it knows to set the nozzle to the right height to achieve this right here. It needs to be whatever it's set at. I don't know if I can see where it is in this particular firmware, but it would tell you in some of them what your Z offset's set at. I don't think I can see it in this one. No, I don't think so. Nope. Okay, so it doesn't matter. Most firmwares will tell you what your Z offset is in the menus. For example, one of my friends, I sent his machine back to him, and his number was 0.0833. So, for that particular filament. That's something else I want to mention too. Each filament is different. You may have to do this test when you change filaments. If your filament is wet, you might have some different results. You might even get a filament dryer. But each filament's different. Brand to brand especially, color to color, they have different compositions for different colors. So you might have to fine tune them. What I normally will do is I will write it on a roll if I know for a fact that this likes to be set at, let's just say, 200 degrees, 50 degrees on the bed, and my Z offset was 0.881, something like that. I would write all that right down on this cardboard with a Sharpie. And so when I unload that roll and I load something in and come back to this roll later on, I know that that's going to be a ballpark. It doesn't mean it's going to be exact. It'll be a ballpark. Same thing with flow, slicer flow settings, initial flow settings. Those are a different topic, but it's another set you have to do. Part of your calibration settings. After this, that would be the next step that I would do. So now we have a good Z offset. We know where that is. In theory, we're technically ready to print. We could print like this, so we could print whatever we wanted to. However, if you don't set your flow, and you don't set some of your other settings that you got to go through, the calibrations you really should go through, then you're going to find you're going to have trouble with over extrusion or messy print, stringing, a lot of blobbing, things like that. Those are all things that can be adjusted down the road. There's about 3 more tests you should do on a new roll of filament. Temperature tower being one of them, retraction tower being one of them, and most importantly, your flow test. If you don't want to go through the flow testing, you can set 90% in your slicer under material flow and material flow, initial flow settings. Both of those could be set to 90%. If you set those at 90%, it's a general happy zone for most printers. When I do the actual flow test, a lot of printers seem to land anywhere between 88% and 94%. So I usually say set 90 and try it. If you like what you see, great. If you like what you saw as a change and you want to get it dialed in perfectly, head over to Teaching Tech, his website, and go ahead and look at what he does for his test. He has a specific test for that exact thing. I'll try to post some links down in either the description of this video, or maybe I'll put it in on the screen or something. It's also available on my website, and in the group chat. If you go into our Facebook group, I talk about that site all the time. It is Teaching Tech YT. You know what? I forget what it actually is. Do I have it written down? I do. It is teachingtechyt.github, GITHUB.io. That is the website. So it's teachingtechyt.github.io. That'll bring you to his calibration page. And it's a really great page for setting up printers. So that's basically my explanation on this whole thing. I thank you for watching. If you have any questions, reach out to me and I'll try to explain things in detail. If you feel like there's something that you didn't understand or you want a better explanation of it, I'll try my best to make it so you understand it. It's not really a complicated subject, but it is a confusing one. I can see why people get... Everybody in the internet tells everybody to run to bed leveling. First thing they say is your bed level? Is your bed level? Your bed could be level and you could still have problems like this. This has nothing to do with leveling. Part of the reason why I did this was to show you that somebody's going to see this and say your bed's not level right there, you're warped right there, you got a problem right there. No, I was adjusting my Z offset. I needed to fix my Z offset to get this. And the reason why I got this goes back to making sure the bed was level all the way around with that perimeter test that I did. And all the plastic looking about the same. From there, over to this side, to that corner, to that corner. It was consistent. Which means that once that's consistent and I set my Z offset to get this, it should be like this all over no matter where I print. It's going to be nice and flat like this because my bed is already level, so it's straight to the head. And the head is being set by the Z offset. You should be good to go. If you have any questions, just let me know. Thanks.